Hello all, welcome back to EduMoon tutorials. In this video we shall discuss about how to convert a regular expression to an NFA with epsilon moves. So let us take initially two symbols like 0 and 1, and I write two machines which are accepting this 0 and 1, a simple machines which is accepting just a 0 and the other machine just accepting 1. So I like to design two machines like M1 and M2 which are accepting only a 0 and a 1. So let this be the first machine will be M1 and the second one will be M2. So both are individual machines. Now we combine this using the epsilon moves with the regular expression. So the basic regular expression operations are union, concatenation, closure. So 0 plus 1 is a machine which accepts either 0 or 1. So from the above two definitions we have seen already for M1 and M2. We can create a machine which is accepted by either M1 or M2 using an epsilon moves. So that goes like, so for the 0 plus 1 we can design a machine in this way, where from the starting state we can take in an epsilon move, that is without reading any symbol. You can go to the machine M1 where it gets forwarded by an input symbol 0, and again the epsilon moves it goes to final state. Or else it can come with an epsilon move to the second machine M2 and it gets forwarded by a symbol input symbol 1 and then gets accepted again. So this is how we can write for a 0 plus 1, which is nothing but an union operation. And now we go with the 0.1, that is concatenation here. So for simplicity purpose I am not writing anything in the states. You can be writing A, B, C, D or Q1, Q2, Q3 and so on. Just for simple understanding I am just ignoring the name of the states here. So we can add them in the later cases. So now 0.1 can be written as, first of all we go with the epsilon moves and we go with machine 1, and after machine 1 accepts that 0, it is forwarded to machine 2. So 0.1 can be written as this one, where it is followed by, that is M1 followed by M2 machine, and finally it gets accepted in the final state. So if it is 1.0, I think you can understand that first of all M2 machine will be processing that, and then we go with the M1. Now finally going with the 0 star, that is a closure operator here. This is how we design for a 0 star, where without any symbols we can already get accepted, because epsilon is also part of 0 star. So only with an epsilon mode goes to final state. And for example it can generate the strings like, for example this one will generate the strings like epsilon 0 0 0 0 0 0 and so on, any number of zeros. So what we write here is, with the epsilon moves you can go to this final state, or else if there is a 1 0, with the epsilon moves you come here, we get forwarded with 1 0 here and it gets accepted here. And if at all there are 2 zeros, from here after reading the first symbol again you come back with an epsilon move here, so it reads the second symbol 0 and then goes to the final state. So any number of zeros will be accepted in this one, in this loop here, and finally goes to the final state. So this is how we design for 0 star. Now using these three basic principles here, we try to design an NFA with epsilon moves for a regular expression with some complex regular expressions here. We will take an example. So we keep this aside here so that you can easily verify this. So let us take an example of a regular expression as, so as a first example we took the regular expression as 0 0 0 plus 1 and 1 1 star. So you can see that we have missed the dot operator there, but you can assume that is 0.0.0 plus 1.1.1 star. So now we try to design a machine step by step. So initially we put that string as the expression in between the initial and final states like this one. So the regular expression I have written between the initial and final states like 0 0 0 plus 1 1 1 star. Now we try to expand this one. So using the rules we have there. So initially there is a dot operator between all of them. So we use the second case here, what we already have here, this one. So this is how we design that. So here totally we have something like 4 dot operators. So we expand that like, that is how we expand that. And in this already the states, for example if you write the statements from the second state and the third state, there is only a symbol 0. but you can see in the fourth and fifth state there is a 0 plus 1 in this case. So that 0 plus 1 we are going to use the first rule here, what we have used here. So we use that rule here and we try to expand that. So this is how we expanded 0 plus 1 using the closure rule. That is all. That is, we put this entire machine over here in place of 0 plus 1 here. So we get that expanded. Now finally in the regular expression there is only one more property, that is 1 star here. So we are going to expand that 1 star using the same diagram what we used for here, 0 star. So the final diagram will be like. So for the better understanding, I have given that expansion of 1 star in that red here. You can see it in the red color. So this is how we design for 0, 0, 0 plus 1, 1, 1 star. So you can see here the symbol 0, 0, this is 0 plus 1, 1, 1 star. That is how we design the NFA with epsilon moves for the regular expression. And we can write the number of states here like Q1, Q2, Q3 and so on up to QF. So initially we can put it like the first state as Q0, this is always Q0 here, and this is something like QF, and we can expand that middle states with giving some numbers like Q1, Q2, Q3 and so on. So initially we don't know how many states will be there. So at the final we get an NFA with epsilon moves. So we do one more example with this case as follows. Now this is second example, we took like 0, 0 plus 1 star plus 0 plus 1 star 1. So this regular expression is nothing but a machine that is accepting strings which are either starting with 0 or ending with 1. That is the regular expression designed for. So now we convert this regular expression for NFA with epsilon moves. So initially we take the initial state and the final state. So this is the first step. Now we can divide this one using that union operator initially, because the first union operator is between the first part of the regular expression like this one. So assuming that is the union operator between 0, 0 plus 1 star and 0 plus 1 star and 1. So expand that union first. So it looks like. So you can see it in the red color where 0, 0 plus 1 star and 0 plus 1 star 1 are divided using that union operator here. So that is the result of the first operation here. So in the first part, that is 0 plus 1 star, now we try to expand that using the concatenation rule here. So this is the result after applying the concatenation rule here. We did the 2 steps in the single step, just combined that because of some space complexity here. So we already applied that 0 dot operation here and also here. We used the concatenation here and as well as here, so we expanded that. And now we simply expand this 0 plus 1 star and 0 plus 1 star. So I am going to do that in a single step so that we can complete the entire answer in the single view here. So therefore this is how we expand that 0 plus 1 star, so which is marked on the red here. That is what we expanded, that 0 plus 1 in the first case, and in the black here that is 0 plus 1 star in the second case here. So I did it in the same step so that we can cover the entire answer in the single page here. So this is how the expansion of a regular expression, or else converting a regular expression to an NFA with epsilon moves is done. So again, we already discussed how to convert NFA with epsilon moves to NFA without epsilon moves, and finally NFA to a DFA. So the relation will be like, we can convert any regular expression to an NFA with epsilon moves, and from NFA with epsilon moves to NFA, and from NFA to DFA, and in the later class we can see how to convert a DFA to a regular expression. In the next video we will see about how to minimize a finite automata. There are 2 ways to minimize a finite automata. So one is partition method and Myhill-Nerod theorem. So we go with the minimization in the next class. Thank you all.